Number 61. How long after 10:10 does it take the hour and minute hands of a clock to align? So we can use a formula. M equals 60h over 11. And what this will tell us is, depending on the hour, h, it'll tell us at what time or at what minute the hands will align. So during the hour of 10, during 10 o'clock from 10 to 11, we know that it will align at 60 times 10 over 11 minutes. So 60 times 10 over 11 minutes is 54.545 minutes. So the clock will align at around 10:54. So if it's already 10:10, then the number of minutes until then will just be that number minus 10. So this minus 10 will give us just 44.5 minutes. 44.5 minutes. All right, let's move on to number 62. So the odds of being attacked by a shark are 1 in 3,748,067. What is this small fraction raised to the 81,245th power? So I'm going to rewrite this a little bit. I'm going to say this is 1 over 3,748,067 to the power of 8,245. And so if you just type this in your calculator, we can see that this is just going to, it's just going to say 0. So to the 8,245, it's just going to say 0. And that's because this number is so small that your calculator doesn't have enough exponents, or it doesn't go high enough in the exponentials to account for this. So we're going to have to use some logarithms. And in fact, number 62 is always going to be a problem like this. So what we're going to do is we're going to take the log of both sides, and then we're going to do some operations, and then in the end, we're going to do 10 to the x. So it'll undo that, and we'll get the final answer. So if I take the log of this, for any case that I take the log of a to the b power, this is equal to b times the log of a. This is just a property of logarithms. So if I apply this to this equation right here, I get 81,245 times the log of 1 over 3,748,067. So let's see what that is. So 81,245 times the log of 81,245. You see right here there's a spot to put the base, but if you just leave it empty, it'll just assume base 10. So when we do this, we get, let's see. Nope, it's not supposed to be 81245. It's supposed to be of 1 over 3748067. Sorry, I just typed the wrong thing. Here, let me just clarify real quick in case that was confusing. So I take the log of this right here. This 81245 will come out front, and then I'll just take the log of what's inside the parentheses, the log of the base. So when I do that, this is what I get from my calculator. Hopefully that clears that up. Sorry, I didn't mean to do that. All right, so we get negative 534,088. So I'm actually going to separate this into 2 bits. I'm going to separate it out into minus 534,089. So if I add 534,089, so let's see, I'll go back over here. I'll separate this into 534,089, so that's negative, plus this 0.0222. And the reason I'm doing this is because this part right here is going to help me with my exponent on the 10 to the x, and this part is going to be the 3 sig figs, also known as the mantissa. So if I raise this, if I do 10 to this, 10 to the negative 534,089, 534,089 plus 0.0222. Because of properties of exponents, I can just split this up into two separate things. This will be 10 to the negative 534,089 times 10 to the 0.0222. And of course, this part is just going to be the exponent on our answer. So we'll have it times 10 to the minus 534,089. And then as far as the second part, we'll just have 10 to this right here, and we get 1.05. So our final answer will be 1.05 times 10 to the minus 534,089. All right, and finally, on to number 63. So number 63 is always going to be a projectile motion question, and it's just a handful of formulas you have to memorize, but I'm only going to tell you the ones for this specific question for now. So the first thing you always want to do is check and see what our final units are going to be. And right here we have degrees, so the first thing I'm going to do before I even start is change my calculator into degrees, just to prevent any confusion. So there we go. And then the second thing I like to do is take my speeds and convert them into either feet per second or meters per second. And the reason for that is because I have acceleration due to gravity memorized in terms of meters per second squared and feet per second squared. So if you have 120 miles per hour, all you have to know is that 15 miles per hour is equal to 22 feet per second. So if I do a little bit of dimensional analysis, 120 miles per hour, and then on bottom I'll have 15 miles per hour, on top I'll have 22 feet per second. So 120 over 15 is 8. 8 times 22, that is 176 feet per second. So our velocity is 176 feet per second. I'm just going to erase this and write that up at the top. Velocity is 176 feet per second. Cool. All right. So what other information do they give us? So an archer fires an arrow with a release velocity of 120 miles per hour or 176 feet per second. What is the release angle relative to the horizontal if the time of flight is 4 seconds? So for the time of flight, we can use this formula for the time of flight on a level surface. The time of flight, I'll write as, here, 1 second. I'll write it as TOF, time of flight, equals 2 times the velocity times the sine of the angle divided by acceleration due to gravity. So we can just plug in our known values. So if the time of flight is 4 seconds, so it's going to be 4 equals 2 times 176 feet per second times sine of theta divided by g. And since we're using feet per second, you have to make sure to use gravity in terms of feet per second squared. And gravity in units of feet per second squared is going to be 32.174 feet per second squared. That's just one that's good to have memorized. So I can solve for sine of theta. So sine of theta will be 4 times 32.174 divided by 2 times 176. So let's see what that is. So 4 times 32.174 divided by 2 times 176. Oh, I messed up syntax. So we get sine theta is equal to 0.3656. And so if we want to find theta, we just take the inverse sine. So sine theta, inverse sine of 0.3656 is going to be equal to 21.4 degrees. 21.4 degrees, and that is our final answer. And I think I may have said this earlier, but remember, number 63 is always going to be a projectile motion question. So this is a good one to practice because you know it's always going to be this kind of question. All right, so anyway, if you have any questions from other tests, make sure to leave a comment and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.